Hey everybody, we are so close to finishing our interpretation of the t-value. I know I've been kind of throwing a lot at you. This is all important stuff, however. Statistical significance, what that actually means, the degrees of freedom, all of this is very important for the rest of statistics as well. So that's why we're covering it right here. Luckily, we won't have to cover it in future tests because it'll all still be applicable to all of those. So this is also vital for your understanding of statistics just generally, and so I think it's important that we go through this. We have one final thing to do before we actually interpret the t-value, so let's get going on that. Okay, a quick recap of where we are if you've not been following these in sequence. We found a t-value, we calculated a t-value from some data that I made up of negative 2.62. And we also know that we have 11 degrees of freedom. We did that in the last video. So if you're not sure how we got there or you're not sure what that means, please go see those. Our question now is our t-value of negative 2.62 unusual enough that we can say that our independent variable actually had an effect on our dependent variable? Or did it not? And so now we have to go back to the drawing board to figure out if there's a relationship, or if it matters which pamphlet that we give to people to increase their fire safety knowledge. Now, to get to this point, we need to look at Appendix B in the back of my textbook. If you're not using my textbook, your textbook definitely has a t-distribution table. If you're not using a textbook, you can Google this. There are lots of them out there. There's also some calculators online. It doesn't really matter what you're using. Just make sure that you're familiar with how to read the table. I, of course, am just going to use mine. So let's take a look at Appendix B from my textbook. This is Appendix B from my textbook. If you look at it, you'll just kind of see this. It's a table underneath this graph. And so we're not going to get deep into the appendix just yet. We're just going to talk about this broad difference here. We have two columns, large columns. These values all have to do with something called a two-tailed test criterion. And over here, the right columns have to do with the one-tailed test criterion. So in other words, before we can interpret our t-value, we need to know which of these criteria are we using. That's what we're going to talk about in this entire video. So let me explain first what it means to have a two-tailed test criterion. When we have a two-tailed test criterion, what we're looking at is our alternative hypothesis. The null hypothesis, the default hypothesis, is always that there's no effect of the independent variable on the dependent variable. Okay, but our alternative could be a couple of different things. Usually, and the one that I've introduced to you, is that I just want to know which mean is bigger than which other mean. I don't care which one it is. It could be group 1, could be group 2. I don't know. I'm just curious to see which mean is bigger than the other mean. Okay, that is a two-tailed test because we're leaving both possibilities open. I'll give you a visual example of this in a moment of what I mean by the tails. But if this is what your alternative hypothesis looks like, where you're just saying, I don't think they're the same, or this is the possibility that they're not the same, you're not specifying which one is bigger than the other, and so either one could be true. It could be the green pamphlet group got a higher mean, or it could be the red pamphlet group got a higher mean, and it doesn't really matter. You could also look at the wording of the alternative hypotheses if it's in words. For example, if I had a research project where I said, I want to know if my sleep pattern changes when I drink a cup of warm milk before bed. If I specifically say changes, I'm not specifying whether it improves or gets worse. That would imply some kind of direction. I would say something like I expect the mean of my sleep quality or whatever, my sleep pattern, to go down or to go up based on whether I drink a warm cup of milk. But if I just say I don't know, I want to see if it changes, I'm not specifying a direction. Another example would be which of my cars gets better gas mileage. Let's say I have a Jeep and a Ferrari. I don't have either of those actually, but let's imagine that I have those and I'm curious. I don't know which one gets better gas mileage, so I'm going to run a few tests to figure that out. If I don't know, if I'm not saying I bet my Jeep gets better gas mileage than my Ferrari, then I'm leaving it open to either possibility. That's all this really is. Let's take a visual look at what I'm talking about when I mean two tails. So this is that distribution of t-values. We talked about this last time as well. So this is t-values. And what I'm doing here, we've seen this actually graphed before, right? What I'm interested in a two-tailed test is I'm saying if mean 1 is larger than mean 2, what's going to happen is I'm going to get a positive t-value, okay? And if it's unusual enough, if they're different enough, those two groups, and mean one is sufficiently larger than group two, I should find a positive t-value, and it will be rare enough that it occurs only 2.5% of the time if there's no effect of my independent variable on my dependent variable. Now, I also, however, say, what if mean 1 is smaller than mean 2? In that instance, I'm going to get a negative t-value because the mean of group 1 would be smaller than the mean of group 2. Therefore, my t must be negative. You'll recall that's what we found is a negative t-value in this particular example we've been using. Our t-value is negative 2.62. So we're looking now down here in the unusually negative or the negative values of t that are unusual. And we're curious if our t value falls on this end. So the point is, because we're leaving it open to either an unusually negative t value or an unusually positive t value, mean 1 could be bigger than mean 2, or mean 2 could be bigger than mean 1. Now we're looking at a two-tailed test criterion. So that's what we're using for our particular test. Now, what is the alternative? A one-tailed test is the alternative here. A one-tailed test is something that you use probably infrequently. At least in my own research, I don't usually use the one-tailed test criterion for a reason I'll talk about here in a moment. However, it's perfectly appropriate in some circumstances. What it does is it says, I'm pretty sure I know which of these is going to be bigger than the other, and I'm going to specify that. I'm going to say, I really think my Jeep gets better gas mileage than my Ferrari, for example. If you're really pretty sure about that, you can go ahead and say that and make your Jeep group 1 and make your Ferrari group 2. And then you've put all of your eggs in one basket, so to speak, and said, I just think I'm going to look at these positive t values. Okay? So as an alternative hypothesis, instead of saying, I don't think the means are different, that's my default hypothesis, I would say, I'm going to specify. In this case, I think mean 1 is bigger than mean 2. I put all of my eggs in one basket, so to speak, and said, I'm going to ignore the negative values of t and just focus on the positive values of t to see if I can find statistical significance there. Here's another way of thinking of this. If I specify the direction, for example, of the difference I expect to find, that's a good sign that it's a one-tailed test criterion. Excuse me. For example, I might say, does my forensic science class do better on their exam with one more lecture? I didn't leave it open to them doing worse with one more lecture. In fact, I don't have any reason to think that giving them one more lecture would make them do worse on the exam. That doesn't make sense, right? So why would I leave that possibility open? Why would I waste all of this time looking at the negative t values if I really don't expect that to occur? Another one might be, does bleach kill more bacteria than doing nothing? It'd be weird to think that bleach would kill less bacteria than doing nothing, or fewer bacteria than doing nothing. And so why leave that possibility open? Why waste all of my why waste my time leaving that possibility there? And one more, does a humidity of 40 feel that much worse than a humidity of 30? Now, if I'm not leaving it open to it feeling better than a humidity of 30, then why waste the time why waste my possibilities of statistically significant values? So let me show you this visually in a second. We'll do one more, however. Do I smell that much worse if I don't shower for 48 hours? Do I have any reason to believe that I would smell better after not showering for 48 hours? Probably not. But do I smell that much worse after 48 hours, or is it fine? Maybe I smell the same as I do after not showering for 24 hours versus 48 hours, right? So if I'm not leaving that open to it being better, then why waste the criteria? Why waste the possibilities of the t value? Let's take a look at this visually. So here is, again, the t values. However, as you can see, what I've done is instead of leaving it open to also searching for those unusual negative t values, if I'm saying I really don't think I'm going to get a negative t value, I just can't see group 1's mean being smaller than group 2's mean. So I'm going to throw that out, and instead I'm going to put all of my 5% on one side of the t distribution. Now, what that effectively does is it says now I get to lower my threshold for statistical significance, because this used to be only 2.5, and so I had to move this threshold up here. But now I'm saying all of my 5% I'm going to leave on one side of the distribution, hence one tail of the distribution, hence the one-tailed test. And I'm going to say any one of these, I think that's what I'm going to go for. Now, of course, this has the other problem of, if it is different, or if you've got if group 1's mean actually is a little smaller than group 2's mean, or if it's unusually smaller than group 2's mean, now you don't get to say that it was statistically significant because you didn't leave that possibility open. So it's definitely appropriate for some circumstances, but don't misuse it, especially if it's totally possible that either mean could be bigger. You don't want to artificially lower the threshold just because you really want to say you found statistical significance. Now, I could continue to talk about that, but I'll leave that there. Okay. So generally, we start off with two tails as our threshold, unless we have good reason to believe that it is only one-tailed was perfectly appropriate. And again, sometimes that is perfectly appropriate. Now, I'm going to quiz you just a little bit. Let's see if you can figure out if this should use a one-tailed test criterion or a two-tailed test criterion. So I'll ask you and then pause the video before I give you the answer. Okay, in this one, a researcher wonders whether breastfed babies' brains are different sizes than those of formula-fed babies. Okay, the key word here is that I said different sizes. Because I said different sizes, I didn't specify whether they were bigger or smaller. So this researcher seems to be leaving it open to either possibility. Either they're larger on average or smaller than average. Therefore, that is a two-tailed test criterion. Now, if the researcher said, I really don't expect they would be smaller, I really think they're going to be bigger than formula-fed babies, that would be a one-tailed test criterion. Let's try another one. A researcher wants to know whether testosterone levels change in elderly males after taking a pill. Now, again, the key word here is change. I didn't say it gets higher. I didn't say gets lower. This one says change. Didn't specify whether it would get higher or small or lower, I should say. And so therefore, this is a two-tailed test criterion as well. Now, if the researcher did specify and said, I really think testosterone levels are going to rise in elderly males after taking a pill, now we're talking about a one-tailed test criterion. Okay, and the third one, a researcher hypothesizes that new mothers get less sleep than their childless peers, and there's no reason to believe that they would get more sleep than their childless peers. And by the way, yeah, if you have ever had a kid or know somebody who's had a kid, that's definitely ridiculous to think that a childless peer would be getting less sleep than a peer with a mother, or I'm sorry, a peer with a child. That's ridiculous, especially a newborn, right? So because I'm not leaving the possibility open for these new mothers getting more sleep than their childless peers, this is a one-tailed test criterion. I am saying I'm putting all of my eggs in one basket and assuming that if I find a difference at all, it's going to be that the mothers are getting less sleep than their childless peers. Now, if you have a good idea of where that difference is going to be and you just want increased sensitivity, like you don't necessarily know, but you really want to increase that sensitivity towards finding a difference if it's there, then using this one-tailed test criterion is perfectly reasonable, as I've talked about before. Okay, so here's a recap of everything we've done. So the things that we need to know before we can interpret our t-value, we need to know, number one, its value, right? We need to figure out what it is. In this particular case, we found it's negative 2.62. We need to know the degrees of freedom we had for it. In this case, we had 11 degrees of freedom. And then the next thing we needed to figure out is, are we using the one-tailed test criterion or the two-tailed test criterion? We will pick up here and finally interpret our actual t-value in the next video. All right, now we use one-tailed test if we're pretty sure where the difference is, and we use two-tailed test if we're not sure and it could be either mean is bigger than either other mean. All right, that's it for now. I will see you next time and we will actually interpret our t-value.